Okay, as promised, I said I'd do a little YouTube videoing for you. And so here it is. Here's the first section. As was set, if you go on to the blog site, you'll see that the work that has been set for you is here. Here is the work that you've been asked to do. Please note as well that I've just uploaded a continuous assessment. Okay. Right, let's on with this chapter 3 work. Okay, now don't be expecting something fantastic, as I've sort of rushed this through so I can get some work out to you or get some support out to you as quickly as possible. Okay, now let's have a look. Simultaneous equations. There's a lot of simultaneous equations in here which you should have done through your GCSE, and this is really just to make sure that you do understand it all. First type of solution is by elimination. This is where we're going to try and get rid of one of the variables so that we can find the answer to one variable, use that as a substitution, and then find the answer to the next variable. So for example, if we have two equations like this, 4x plus 3y equals 23 and x plus y equals 6, what our goal is going to be is to get the number of y's. Now it's the absolute number of y's because I don't really care whether it's plus or minus, but I want to get the same absolute number of y's in both equations. That's step 1. So I take x plus y and I multiply that by 3. Okay. Now one of the key things here is that people often forget to multiply this answer by 3 as well, and so they'll make the mistake of writing 3x plus 3y equals 6, which, you know, obviously people like you, Georgia, will not make that mistake, and Liam, I hope you're the same. So use either subtraction or addition then to eliminate the variable. There is a simple rule to this. If both the signs are positive or both signs are negative, we're going to use subtraction. If they're different, so one's positive, one's negative, then we use addition. Then we're going to use addition. The reason is that subtraction will get rid of the 3's or get rid of the y's if they're both the same sign, and addition will do the same thing. So if we do that, here we can see that 3y take 3y, well that's nothing. 4x take 3x, that's x. 23 take 18, that's 5. Then we use this value back into one of the equations. So what I do suggest strongly here is you use one of the original equations and don't use the multiplied out equation that you've got, because if you've made a mistake, I suppose the whole thing's going to be wrong really. But if at least if you go back into the original equations, then you might have a chance of finding out that it is wrong and then realizing you've made a mistake and going and correct it. Step 4, check both values in the other equation. So go back up again to the original, one of the original equations, the one you haven't used, to find y, and put it in and just check that it works. This is one of the good things about simultaneous equations, in that you have two values and two equations, which is essential, and you have the opportunity then to check back that your work is correct. Okay, let's just have a look here. There's a further example. Sometimes one equation does not simply multiply to give the same absolute coefficient of one variable as in the other equation. So if we look at these two, you can see that that's got 2y and 3y. Now, there's no number which I can multiply 2 by unless I multiply by 1.5, and I don't really want to be multiplying by 1.5. What I can do then instead, sorry, no number which we multiply 2 by to get 3 apart from 1.5. That's what I meant to say. So what I'm going to do then is if I multiply this one by 3, that will get me 6y. And if I multiply this one by 2, that will also get me 6y. So there's no problem in multiplying both equations. Then I can run through the same process that I did before, where 9x plus 6y, 4x plus 6y. So the x's the y's effectively cancel out, leaving me 5x equals 2. So 5x equals 10 and x equals 2. It's getting a bit in front of myself. Thanks for correcting me, Chardon. And so y equals 3. Okay. And that's just on elimination. If you want to move on to the next lesson, that will be on solving simultaneous equations by substitution.